Welcome back to our channel. Have you ever tried to sleep while standing up? It seems quite impossible, doesn't it? We humans would quickly lose our balance and tumble over. We seek the comfort of a bed, a place to lie down and let our muscles completely relax. The very idea of dozing off on our own 2 feet feels like a circus trick, something reserved for performers with incredible balance. Yet in the natural world, this feat is not a trick at all. For many creatures, it is a simple, everyday part of life. It is a necessary adaptation for survival in a world full of constant challenges and dangers. For countless birds, sleeping while standing is perfectly normal. They do it every single night, without a second thought. From the smallest sparrow perched on a delicate twig to the tallest stork standing in a shallow marsh, this ability is widespread. They settle down as dusk falls, fluff up their feathers, and drift into a state of rest. They do not need a nest or a hollow log to feel secure. Their own bodies provide the stability they require. This remarkable skill allows them to rest in places that might seem precarious to us, but are, for them, the safest havens available. So how do they do it? How does a bird manage to stay perfectly balanced on a thin branch while completely asleep? The secret isn't conscious effort. It's a brilliant piece of natural engineering in their legs. Birds have a mechanism called the perching reflex. Tendons run down the back of their legs in a unique arrangement. These tendons are different from ours. They lock automatically when a bird bends its knees and when it bends its ankles. That happens naturally as it settles onto a perch. It's involuntary, requiring no thought at all. The locking works like a ratchet. When a bird lands on a branch and squats down, its body weight pulls the tendons tight. That forces the toes to curl and grip the perch. The bird doesn't actively squeeze. The tendons do the work. They create a clamp that won't release while the legs stay bent. It's a passive system that uses almost no energy. The primary reason for this remarkable standing sleep adaptation is, quite simply, safety. The world can be a very dangerous place for a small sleeping creature. On the ground, a bird is vulnerable to a wide array of predators: cats, weasels, foxes. They use the cover of darkness to hunt, and a sleeping bird on the ground would make an easy target. By roosting high up in the branches of trees and shrubs, birds elevate themselves out of the immediate reach of these terrestrial threats. It is a simple, vertical escape that gives them a crucial defensive advantage. Sleeping on a perch does more than create distance. It also acts as an early warning system. If a predator like a snake tries to climb, or a climbing mammal does, the movement causes vibrations in the branch. Those subtle tremors travel up through the bird's locked feet and legs, startling it awake long before the threat gets close. For many species, safety is found in numbers. Starlings, they often gather in large communal roosts at night. A single alarm call can send the whole flock into the air in a flurry of wings. The strategy of sleeping on one's feet is not exclusive to birds that live in trees. Many long-legged wading birds also use this trick, starting with storks. Next, herons. And of course, the iconic flamingo. Their home isn't the forest canopy, it's wide-open wetlands, marshes, shallow lakes. Standing in the water brings its own challenges. It can be cold. Predators like crocodiles can lurk below, or alligators. So standing tall, often on one leg, is their solution to rest safely. The flamingo is the most famous example of sleeping while standing. Scientists long debated why they do it. Was it to reduce muscle fatigue? Was it related to how their brains sleep? Recent studies point to a mechanical answer: energy conservation. A flamingo's body is balanced so its leg can lock straight with little effort, like a passive stay apparatus. It essentially rests on its own skeleton and can stand for hours without tiring. Standing on one leg also helps regulate body temperature. Water draws heat away far faster than air. Tucking one leg up into its warm, feathery body reduces exposed surface area. They can simply put their second foot down, then spread their wings and lift off, leaving danger behind. Perhaps the most astonishing aspect of how birds sleep is not in their legs, but in their brains. Many birds have developed an ability known as unihemispheric slow-wave sleep. They can literally put one half of their brain to sleep at a time while the other half remains awake and alert. When a bird does this, the eye connected to the sleeping hemisphere closes, while the eye connected to the awake hemisphere stays open, ever watchful for danger. It is the ultimate form of sleeping with one eye open. A bird sleeping on the edge of a flock, for example, will tend to keep the half of its brain facing away from the group awake, keeping its open eye pointed towards the direction from which danger is most likely to appear. Birds sleeping more centrally within the flock, surrounded and protected by their neighbors, are more likely to let both halves of their brain sleep at once, entering a deeper, more vulnerable state of rest. This creates a selfish herd effect where the safest place to be is in the middle. The birds on the periphery act as unwitting sentinels for the entire group. This flexibility, the ability to switch between half-brain sleep and full-brain sleep, gives them a dynamic way to balance the need for rest with the need for vigilance, depending on their situation. So, the next time you see a duck seemingly dozing on a pond or a pigeon resting on a ledge, remember the complex processes at play. It may not just be its locking legs that keep it safe, but also its half-awake brain. It is a perfect, living demonstration of nature's ingenuity, proving that even in sleep, survival is always the top priority.